Sitting on top of this Falcon 9 rocket at Launch Pad 39A at the Kennedy Space Center is NASA's latest instrument that will be sent to the International Space Station. It's called SAGE 3, and it will be used to monitor and measure something that is important to the entire human race and every other living thing on the planet: Earth's precious atmosphere. For many of us in the general public, this looks like just another one of the hundreds of launches that we've seen NASA perform over its 50-year history. But for the scientists, engineers, and support staff who have spent years of their lives preparing for this moment, this launch represents the culmination of all their efforts. It is impossible to calculate how much planning, execution, and sacrifice this team has made to get this instrument to this point. But suffice it to say, there have been many sleepless nights and long hours getting everything just right. So it's easy to understand why so many of these engineers and scientists are holding their breath at this moment. Although this is not the first SAGE instrument to go to space, it is the latest and most complex, since scientists first realized that Earth's fragile atmosphere was thinning further and in need of monitoring. Because this mission is so important, the tension is high for the SAGE team. Have they checked everything? Will the rocket work? Will this mission be successful? They will know in just a few minutes. On this episode of NASA X, we will go back and look at why the SAGE 3 instrument was developed and get a better understanding of what it will be monitoring. We will also follow some of the team as they prepare the instrument from the beginning to shipping, to the clean room, and eventually into space. And we will be there for the launch to see if everything went as planned or if it reaches its final destination attached to the International Space Station. Here in this building at NASA Langley, some very important cargo is being loaded aboard this truck for a special delivery. Inside this container is the SAGE 3 instrument that has been designed to study aerosol distribution in our atmosphere and to study ozone, which is a gas found in the upper atmosphere that acts as Earth's sunscreen. This cargo's first stop is NASA Kennedy Space Center, but its ultimate destination will be 250 miles above Earth, attached to the International Space Station. More than 25 years ago, scientists realized there was a problem with Earth's protective coat of ozone. It was thinning. So NASA and the world community worked together to send instruments to space that could help us better understand what was happening in the atmosphere. Beginning in the 1970s with the Stratospheric Aerosol Measurement SAM instrument, then SAM-2, SAGE, SAGE-2, SAGE-3 Meteor 3M, and now SAGE-3 ISS have all been invaluable in helping understand Earth's aerosols and Earth's thinning atmosphere. The SAGE family of instruments was pivotal in making accurate measurements of the amount of ozone loss in Earth's atmosphere, and also played a key role in measuring the onset of ozone recovery resulting from the Montreal Protocol, which was passed in 1987. Even after 25 years, the SAGE instrument is still the best instrument for the job, and now, with updated hardware, NASA is preparing to send the third generation of the instrument into space, this time attached to the International Space Station. But before it can be placed on a rocket bound for the ISS, SAGE 3 will have to be retested, making sure any components were not damaged during its journey from Virginia to Florida. That work is being performed in a clean room here at NASA Kennedy's Space Station Processing Facility. The team will go through procedures to make sure that SAGE 3 is in perfect working condition.
This week the team is working to complete the full functional test of the instrument payload. And what that does is it verifies the instrument's the subsystems functions and also test the interfaces between the subsystems. And it's in the clean room because we have to meet contamination control requirements. And those requirements are really important because we do not want any of these, the optical or the radiator surfaces could degrade over time if there's surfaces are contaminated.
To fulfill its scientific goals, SAGE 3 is equipped with a set of tools with a total mass of about 1,162 pounds. Its most important payload is the Sensor Assembly Instrument, a grating spectrometer that measures ultraviolet and visible light and has a 2-axis pointing system. The Sensor Assembly Instrument contains the Charge-Coupled Device Array Detector that enhances measurement capability and may allow for new experimental data products like methane, bromine monoxide, and iodine monoxide, as well as measure larger aerosols. SAGE 3 is also fitted with the Interface Adapter Module, which is characterized as the brain of the instrument payload, the Disturbance Monitoring Package, the Hexapod Pointing System, and the Instrument Control Electronics Box, while the Hexapod Pointing System will act as the legs of the payload, keeping the instrument level in orbit.
Basically, we're exercising all the parts of the payload. We'll do all the things that we're expected to do on orbit. We'll take science data. We have a light source simulator that we use to simulate the sun, and it allows us to take science events. We'll move the hexapod, we'll move the upper platform to different locations. We do a range of motion tests just to make sure that it can cover all the extremes of its envelope. You know, we have some redundancy, so we'll check the main side and the redundant side and make sure we can do things like upload software and run certain commands. Pretty much putting the payload through its paces. And we've done this several times along the way, and then we'll take the data and compare it to the previous tests we've run and make sure that everything is in line, all the data is consistent, and we're getting the results that we expect.
When final power testing was completed, the instrument payload and the Nadir viewing platform were handed over to SpaceX for installation into the Dragon trunk of the Falcon 9 rocket, leaving the SAGE 3 team waiting for a launch. Even with SAGE 3 in the hands of SpaceX, the team continued to go through scenarios preparing for an eventual home on board the ISS.
When we first get mounted to the space station, we actually will be running out of here 24/7 for approximately the first 2 weeks as we power on each subsystem. We've got 5 subsystems, so we power each one up about once a day just to make sure it powers up correctly, check the status of it. And then we'll be doing calibrations, make sure the CCD, which is kind of a fancy digital camera, the main part of the instrument, is calibrated correctly, it points correctly. So we'll be doing that all out of here about 24/7 with a crew of about 8 of us. And then once we finish the commissioning phase, then we'll go more into the routine operations where on a daily basis we'll have someone come in here, they'll check the health and status of the payload, send the commands up that we need to make sure